Hi, today we'll be working on question 221 LeetCode called Maximal Square. So we're given a 2D binary matrix filled with zeros and ones. We want to find the largest square containing only ones and return the area. Cool. So here's our input. In this example, the ones highlighted red represents the greatest area, which is 4. Cool. So this is a DP question because we're choosing whether we want a specific value to be included in our square or not. We can memorize by using previous results from previous squares to add on to our current largest square. So for this, I'm going to call this max length equals 0. We're going to calculate the longest length of the square because we know that if it's a square, the two sides of a square must be equal. So that at the end, we can just return max length squared. Cool. So what about the DP part? So for the DP part, let's use Paint to really illustrate what we're going to do. So first off, we know that in the first column and first row, it's going to be the largest square possible because in this case, we can only choose each of those one elements and we can't go any further. So we'll be updating our DP with everything inside of here. And we know that since a square is only created by using ones, we'll only update every time we pass by a 1. So let's see what happens. So let's take a look at this one. In this one, we have a couple ways to make our longest length. We can take a look to the left for more, up for more, or diagonally for more. So basically, we're going to be making 3 decisions. We're going to be choosing between these 2 values and thinking, which one gives me the largest possible square? So thinking about it rationally, we would always choose the 1 because it has the highest value. But that in fact doesn't make the square because there's this 0 in the way. So in fact, to make sure that it's a valid square, we have to choose the lowest value between these 3. So in such a case, we can say that the minimum is going to be the minimum of the row above, sorry, the row to the left, no, sorry, the row above, the column to the left, or the diagonal to the up left. To illustrate it more, let's take a look at this one for more space. So once again, we extend it through 3 directions. We can either add the one above, the one here, or whatever came out of here. So to do this, we would once again create the 4 kind of um, the 4 squares that we would be currently using, which are these 4, and we would think between these 3, which one would give me the largest area. But once again, because it has to be valid, we always choose the lowest value. So we keep doing this until we get to the bottom, and we'll update our max while we're doing this. Now, here's the other thing. Every single time we add a new one to the square, we're basically adding 1 to the length. So basically, we'll be adding 1 every single time we pass by and do this DP operation. So we can then say DP of ij is going to be equal to the minimum of these 3 things, which include dp of I minus 1 j, aka the tile to the left, dp of I j minus 1, the tile right above, and dp of I minus 1 j minus 1, aka the element to the diagonal left. And since we are once again adding 1 to the length, we'll be adding 1 afterwards. Cool. So let's do this out then. So we can say for now we can say if we pass by a 1 and if our bounds are greater than 0, both of them, because once again, everything in the first row and first column are already at the max area. Then we update that value. So we can say matrix at ij equals max.minimum between matrix I minus 1j, matrix I j minus 1, and matrix I minus 1, j minus 1. Okay, we add 1 because we're adding a new length of 1 to our square. Then at the end, we just get the maximum between itself and our new updated square. Cool, and that's just about it. So let's run this code. Works just fine. It works just fine. Cool. So runtime of this, since we're going through each element at most once in our iteration, this is just O of n times m, where n and m represent the length and width of our matrix, respectively. Cool. So with that, I'll end the question here, but if you have any other questions, please let me know. I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.